Alright, ladies and gentlemen, this final video for section 7 of chapter 2 is going to cover 2 additional segment addition postulate proofs, just to give you 2 more examples to work off of. Hopefully through the first 2 examples in the last video you started to notice some patterns. We are going to cover these a little bit faster because we should have some of these ideas down. Some of the things that we end up doing every time are still going to be happening here. So again, every proof starts the same way. So we're going to start this proof by stating the given, which is that segment WX is congruent to segment YZ. That is our given. Now, even though we have a couple of properties that apply to congruence, most of our properties do not. So we really don't need congruent statements. What we really need are equations. Well, if segment WX is congruent to segment YZ, then the length of WX is equal to the length of YZ. So that allows us to take our given and turn it into an equation in step 2 using the definition of congruence. That is what congruent means. It means they have equal length. In step 3, we'll notice 2 equations. WY is WX plus XY. That is true because WX and Y are collinear and X is between W and Y. XZ equals XY plus YZ. Same deal. Look at the picture. X, Y, and Z are collinear. Y is between X and Z. Both of these equations are true because of the segment addition postulate, which says if 3 points are collinear, one is between the other 2 if and only if they fit that exact equation pattern. So then, that does it for our gather stage. We have 3 equations. 1 equation in step 2, WX equals YZ, and 2 equations in step 3, the 2 segment addition postulate examples. So in step 4, we start our manipulation stage. Now, step 4's equation looks extremely similar to one of the equations in step 3. The only difference is that the YZ portion of the equation in step 3, which I'm going over right now with the highlighter, YZ has been replaced with WX by substituting WX into that equation for YZ. We're allowed to do that because we stated WX is equal to YZ, which means we can substitute WX in for YZ in any equation. So step 4 is a substitution property. We are substituting WX into the equation for YZ. In step 5, you'll notice we have the exact same equation. The only difference is that the left and the right sides of that equation have been flipped. XZ was the left side before, now it's the right side. XY plus WX was the left side, or the right side, now it's the left side. So statement 5 is we're using the symmetric property of equality to flop the left and the right sides around and switch them up. Step 6 says transitive property. Now I'm going to highlight this, but then I'm going to remove the highlights. Remember the pattern for transitive property. Okay, it says if A, here's A, equals B, so here's B, and B, there's B again, equals C, so here's C right here, then A equals C. So when we do this, the transitive property, we're using the first statement from 3, the one we haven't used, this statement, and our statement in step 5 to establish that WY is equal to XZ. Because WY is equal to WX plus XY, WX plus XY is equal to XZ, therefore WY must equal XZ. That is the transitive property. Notice that is what we want to prove, except that's an equation. Well, fortunately, if the length of WY is equal to the length of XZ, then that means that segment WY is congruent to segment YZ because that is the definition of congruence. We're done with this proof. We have one more example in our notes. So we're going to go on and do that example now. So here we go. Okay, this one has a lot of givens. We are given that C is the midpoint of segment AE and that C is the midpoint of segment BD, and that AE is congruent to BD. Just like any other proof, our first step is to restate all of that given information, which you see is done in step 1. So our reason is that is given. Now, if we could use congruent statements, we would use the midpoint theorem here, the one we proved back in section 2-5. However, we don't need congruent statements, we need equality statements, we need equations. So instead of the midpoint theorem, we're going to use definition of midpoint. If C is the midpoint of AE, that means that C is located exactly in the middle of segment AE. In other words, that tells us that the length of AC is equal to the length of CE, because C is the midpoint of AE. Using the exact same argument, since C is also the midpoint of BD, we can state that BC is equal to CD. Both of those statements are true because of the word midpoint in our givens. If C is the midpoint of AE, then each piece of AE must be equal. If C is the midpoint of BD, then each piece of BD must be equal. We're still in the gather stage. Step 3 tells us that AE is equal to BD. Look back at your givens. There's one given that we haven't used yet. That is that AE, segment AE, is congruent to segment BD. If they are congruent, then the definition of congruence tells us that their lengths must be equal. So our reasoning in step 3 is that is the definition of the word congruent, which is shown right here in this given where my pen is moving. See it? If those two line segments are congruent, then their lengths must be equal. AE must equal BD. So we're still in the gathering stage because there's still more information we can get. In that picture up there, C is between A and E, and C is between B and D. So step 4, we are applying our segment addition postulate to acquire those two equations, and that should be something that we all see very clearly by this point. So we have a total of 5 equations we can work with. There are 2 equations in step 2, 1 equation in step 3, and 2 equations in step 4. So step 5, what they've done is they have taken the equations from step 4, AE equals AC plus CE, and they have replaced AE in the statement in statement 3. They did the same thing on the other side of the equation. They replaced BD with BC plus CD. So they're plugging both equations from step 4 into the equation from step 3 to create step 5. That is the substitution property. We are substituting those equations from step 4 into the equation in step 3 to create the equation in step 5. Then, in step 6, they substitute again. This time, they take the fact that CE is equal to AC, and they replace CE with AC. So they're taking the equations from step 2 this time, and they're plugging those, they're plugging those into step 5 to create step 6. So step 6 is also the substitution property. Now, I'm a little bit annoyed with myself for allowing myself to be so informal in step 7. I should not have written simplify. What I should have written there was substitution simplify. Okay, it should say substitution with simplify in parentheses, because we're using the substitution property, but not the same way we just did. We're not plugging one thing into another. We are simplifying. Look at the equation in step 6. Notice that both lengths referenced on each side are the same length. So think about them like variables. If we did x plus x, we can combine those like terms into a 2x. So AC plus AC is 2AC. Okay, so we should be doing that on both sides of the equation. Okay, the left side of the equation should become 2AC, and the right side of the equation should become 2CD. Now that's everything there is starting to look like what we're trying to prove. The problem there is now we have these 2's that we need to get rid of. Well, that's easy. There's a 2 on both sides. So we use in step 8 the division property. Notice we're showing division by 2. So we're dividing each side of the equation by 2. And then once again, I'm mildly annoyed with myself. I should not have the word simplify there. It should say substitution simplify, because it is a formal process and we're using the substitution property to simplify, meaning we're actually carrying out that division. So the 2's on each side will cancel, leaving us with the length of AC equals the length of CD, which means that segment AC is congruent to segment CD, because that is the definition of congruence. That finishes our proof off and gives us 4 good video example proofs of segment addition proofs. Guys, there's only so many of these. They can change the picture, they can change the letters, but the patterns, there's really only a handful of ways to do segment addition proofs. Thank you very much for your time and attention. Remember, you need to be tough. You need to keep trying. It will click. Make sure you know your vocab. Make sure you know your theorems and postulates, and you will get it. Keep working hard, folks. We have faith in you. Thank you for your time.